Hey guys, the new generator's all done, up and running. Our lens assist generator is what I'm going to call it. It's got our plastic rotor on top, a bit hard to see but it's there. Two little neos, our two cores in our toroid. We've got the gap on the magnet's about 10 mil, as you can see there, so that seems to be about where they're happiest. This one here is our voltage in our voltage doubler caps. This one here is going to be the amps coming out of the caps into my flash light I've put here off a four-wheel motorcycle. This one here will be the amps that the system's drawing. I'm running it on 24 volts. This big battery here is the old battery out of my boat. Charged it for 2 days and it wouldn't take any more than 11.69 volts. I've had it running on this setup here for about 4 hours now. And it's sitting just under 15 volts at the moment, so that's come up quite well and quite fast. Like I said, 24 volts here. So what I've done with the generator coils, which is the two smaller ones, I've wired them in parallel to give us a lot more amps to pump into here. Seems they like these voltage doublers like a lower voltage higher amp rather than a higher voltage lower amp. So that's how I've done it. I've put 2 diodes to split the coil. So one side's a halfway of AC and the other side's a halfway AC voltage. Now I'll show you a bit later on why I did that. I just want to test a theory I had. What that's going to do is, normally you would just run it straight off the AC into the voltage doubler, which means as the magnet's approaching the core you get the generated voltage from the coils going in there, and as it's leaving we get that generated voltage as well. So what I've done here is one side will give us just the voltage going into the caps as the magnet's approaching the coil, and the other side will just give us the voltage as the run coil fires and that leaves the coil. The best results are the AC. If I hook it up before the magnet approaches, just like a normal generator, bogs the motor down, nearly stops it. And if I hook it up after, I get a runaway. It speeds up and up and up and just continues to speed up. This voltage continues to climb, but the amp draw on the motor continues to go up as well. So it's happiest just with the straight AC. Right, so what I'll do now, she's all hooked up, ready to go. I'll give her a flick and a start. I'll let it build up speed. It's fairly nice and quiet, this one. This new setup is a whole lot better than the old girl here. When I hook the AC wires up to the caps with that 12 volt LED car light. It's almost instant, up to 12 volts in the caps, getting a lot of amps coming out of the AC generator side of it. This one here, as you know, it did the job, but not so much power coming out of it. I worked out what I could change to make it better. I've had a go at it and it's improved at 100%. Like I said, heaps of amps coming out of there for 2 little coils and those 2 tiny magnets, as you've seen. Okay, about at its best spot. She's drawing 214 milliamps at the moment. We're still pumping 78 milliamps into this big battery. Like I said, that's very close to 15 volts now. So the 4 amp battery charger in 2 days wouldn't lift it any higher than 11.6, and this little thing in 4 hours has lifted it up to nearly 15 volts. So JB's definitely on the money there with his charging systems regarding the pulse motors, no doubt about it. Okay, we've got 1.642 volts in these caps, our voltage doubler. Thanks to Poppy, this thing's just marvellous. I can't work out why I've never heard of it before, so big thanks to Poppy for sharing this with us, because there's a few of us having some fun with it at the moment. Like I said, 215 milliamps from our 24 volts is being drawn at the moment. So what I'm going to do, it's a fairly decent load I've got on here. What I'm going to do is hook up our generator now. Actually, just before I do that, I'll take a RPM reading. Now RPMs are, I was doing 1183 RPM at the moment, and that's where it's settled. So okay, I'm going to hook up the generator now. I'll try and get it both in. Just watch how fast the caps fill up and the light cranks up as soon as I hook it up. There we go. Just like that. They're already up to 12.73, 12.7, 12.8. Now that's the amperage going into those lights at the moment. As you can hear, the rotor speeding up quite nicely. We're now pulling 182 milliamps. So I'll just do an RPM test on our rotor now. Now we're doing 1494. It's still picking up speed. 1514. We're at 12.37. 73 milliamps. So what's feeding that light? 189 milliamps. We're drawing on the pulse motor now. That light's pretty bright. As you can see, the camera auto darkens when it gets too bright, but definitely lights up the show quite nicely. This thing's still speeding up. 1574 now. Turn our pop down a bit. So there you go. That's my lens assisted generator. Now keeping in mind it's not a lensless generator. If you don't have lens force, you'll have no electricity. The key is to be able to use that lens force in a way that it pushes the magnets away when the coil's loaded up, rather than bog the rotor down. So that's running really nice. 73 milliamps at 12.34 volts is driving our 12 volt auto light at the moment. Now the other thing I was going to show you was this. If I take it off here, put it on there, that's just using it as a generator, losing a lot of power. Our milliamps aren't dropping. As you can see, hardly running the light at all. That's normal generated power. Hook it back on, that's how quick. You can even see the sparks this thing makes. And it runs down. But as soon as I hook it up, that's unhooked. That's hooked up. Light goes up bright. Rotor starts picking up. The voltage is coming back up. The amps are coming back up. So what I'll do now is I'm going to run it off the side of the AC after the magnet has passed the core. You're probably thinking that's really good, that's picking up, and it is. It's picking up in RPMs heaps. Our voltage is only 9.7, dropping, and our amps are way up high. So those two ways are no good. It has to be straight AC to get the best results. If I disconnect the generator, if I take the load off the generator, that's our normal pulse motor. Amps go up, flywheel slows down. We're still charging our battery, of course. But yeah, I mean, if we can take power out of a system and reduce the power to drive that system, and also speed up the flywheel, that's got to be really good. So one more time, we'll zero going into our light 188, 187, because the rotor's slowed right down. 7.9 volts in the caps. So I'll try and get the light and the amp draw at the same time. There we go. The rotor's speeding back up. The voltage is slowly climbing. Amps are slowly climbing. So this one's working really nice. Very nice. I haven't in fact checked the AC voltage going into the caps just yet under load, so I'll do that now while we're here. All our meters are timing out. There we go, 5.2 AC volts going into those caps. And hook that back up. 12.11 under load coming out. So that's pretty good. Hand drawing the motor with the generator hooked up. ampere on the motor without the generator hooked up, and the rotor starting to slow down. Hooking back up, beautiful. Rotor speeds up, voltage just go down. So this is actually the first what they call lensless generator. It's actually called lens assist as far as I'm concerned, because the lens force is still there. I've just found a way to use or utilise it to our advantage rather than it being a headache. So that's it, guys. That's my system as it stands at the moment. Cheers from the Tin Man.